Good day, everyone. Robert Wilson here with Southern Hampshire University Game Programming and Development degree. This is the class for GAM415, which is graphical development in Engine. And week 7, or actually, nope, finishing up week 6 here, we're looking at our final project, part A. All right. So for this project here, we had to create projectiles that we shoot with a first-person character gun. Those particles are spawned with a particular randomized color. Impact, put a random decal on any meshes it hits with a Niagara splash effect coming off of it. Additionally, as part of this course, we had to do procedural train generation and set up some portals with some render cameras to be able to see what the other portal is looking at. So without further ado, keep looking over here to the left here to see what project requirements I got. This is the project review for the course, but I'll go ahead and upload this to YouTube for everybody to see, and we'll go ahead and review all the different aspects here. So the first thing, go ahead and hit play. First thing was the projectile mesh. Okay, so you can see it created that procedural train when the game started. It was not there when we were in the editor view. So we'll grab that gun. You can see the projectiles have a randomized color to them. When they hit an object, they create a decal on that object with some particle effects coming off. That met all the projectile mesh requirements. Decals, okay, so you can see the decal matches the color of the projectile. The color, it changes every time you fire. Let's see, looking at the procedural train, so we have a procedural train here. I'll go ahead and press, I think it's Shift F1. We'll look over here on the right side. Scroll down to the, there we go, procedural train. And we can look at the different values we have here. We set all this up in C++. We'll take a look at the code in a bit here. I just wanted to run this over with you guys. Okay, so we set up 300 blocks wide by 300 blocks long. And we do a Z multiplier of 200 using a Perlin noise generator in C++ to create that up-down height differences. We can adjust the noise scale, overall terrain scale, UV scale, that's for our textures, and the radius, so like if we shoot the ground here, so I'll actually come over here, so that's the edge of our static mesh, and this is on our terrain. If we actually shoot the ground, a little bit of a lag for a sec there, but it actually makes a depression down into the ground, and what it's doing is it's recalculating a radius of 200 Unreal units, so 200 centimeters around the projectile, looking at all the vertices, and it's depressing the ground down. You can see depth there of, okay, Shift F1 to get out of, or to get a mouse cursor back, because you can see we're doing a depth of 50 Unreal units, or 50 centimeters down, using a radius of 200 from the point of impact. And then for the material, I just grabbed a generic prototype grid material that is used on the static meshes. All right. Look at the next item here, portals. Okay, so this is a fun one. Oh. All right, falling into the hole here. Get out of the hole. All right, so head over here. I have a pair of portals with render camera attached. So here we go here. So this portal is looking at those blocks over there. You can see the back side of another portal over there. So when I come up to this portal here, this is what it looks like on the other side of the portal. Jump through. And we are now there. You saw that brief camera fade, so I have a 1 second camera fade during the teleport, and then a fade back in once we get to the other side. And then here we can actually see back to our starter spot where we're doing our shooting for the portal that is over there. So we'll go ahead and jump back through. All right. Let's see, so that's our portals. Shift F1, let's see what we got going on over here. Scene captures, run targets, and our materials. Okay, so let's take a little bit closer look at our portals. I'll hit escape here. So the portals, just set up with a it's static mesh. We're using scene capture component 2D. We actually set all this up in C++. We have the portal that this is for the render target, and then we look at what portals it linked to. We can use the eyedropper to pick it, and what view camera we're using to look from that other portal there. So I'm linked to portal 1, and I want to see what is occurring on portal 1 on the current portal that I'm looking at. And same thing goes for the other portal there. Click on that one. That is portal number 1 over there. And I want to link it to portal number 2 that we just have by us. And I want to see what's being displayed on the other side of portal 2. Now, if you look, actually hit play again. Okay, so you can see the blocks, looks real nice there. The portal, it's up against the wall here, so the back of the portal. Okay, so here we're looking from the front, but if we actually go to the back side, we're actually looking at the wall. Back up enough, you can actually see the gun sitting in front of the wall there. We're looking at the back side of the portal, which is actually looking at the wall. Okay, let's take a look over and look at our repository real quick. So we use Bitbucket for this course here to do our updates. So you can see each week I do a different push. So our first week was adding the decals with the projectiles and color, getting color with them. And then we added a Niagara splash effect when those particles hit, and that splash effect color had to match the hit decal and the projectile color. The week after that, we did added procedural terrain. We set the height and the width using those XY values that we defined them in C++, but we can actually set them using Unreal Engine properties. Then we added a portal with the render target, and then finally we set all this up into the level showcase, which we're doing right now. Okay, comment on the code. Yes, that brings us to the C++ code, the favorite part. All right. So for the character, it's just the standard C++ character that you get. There's nothing special been added to the character. Let's take a look at the procedural terrain. This is the fun one. Okay, so in the header, we have our uMaterial instance for setting the terrain material, and we also set the mesh component. In this case, we set it as a cube inside the editor. Our X size is just an int32 and our Y size is int32. We use floats for our Z multiplier, the noise scale, the scale of the terrain, our UV scale for the textures, our radius this is for the shooting the terrain, the radius that of vertices that we want to impact, and then what depth we want to set. We use that as an F vector. So setting the XY, we want to focus on that Z value, on how deep we want to go. Let's see. Here I like defining as a uMaterial instance. You can also do it as a uMaterial interface. If you do it as a uMaterial interface, then you can use a material or material instance inside the editor. I like to limit the user to using a material instance because that is better utilization of how the material system is supposed to be working, of assigning material instances to different materials instead of the master materials themselves. Let's see, and then we just set some private variables for the terrain itself. So we got our vertices as a T arrays. So we got the array of vertices, the array of triangles, the array of UVs, the array of normals, the up vertex colors, and of course we also have our mesh component, which is the procedural mesh. We can break it down in section IDs. That's if we want to break the terrain up into smaller sections. So when you shoot it, right now it recompiles all the triangles. So the larger your terrain is, the bigger lag chunk you'll have. You can actually break that up into sections, so when you shoot it, it only calculates for that section that you're working on. And then we have two functions that we defined. No return values is void, the create vertices and create triangles. Let's jump over to C++, take a look. Okay, we set up our mesh, standard default subject. Come down our begin play. So in the editor view, we do not see the terrain, but once you hit play or the game starts, it goes ahead and calls if the landscape material set, then it goes ahead and calls create vertices, then create triangles. Then it creates the procedural mesh where we create the mesh sections using the different arrays that we have defined. And then we go ahead and set the material to that procedural mesh, which is why we had to do that landscape material check. Okay, we'll take a look down at the create vertices and create triangles. In the event tick, we want to alter our mesh. It does it every it does it every. Actually, no, we didn't put in tick. Good. Okay, I thought this was one we put in the tick. Okay, so we have the alter mesh. This is the one that allows us to add the depth, adjusting the vertices here. So when you shoot it, it actually goes through all the different vertices, finds the vertices that we actually hit, which is the impact point, minus this actor's location. And then we go ahead and adjust the size by taking the vertice minus that depth value that we set in Unreal Engine, because it is a share or public property. And then it go ahead and resets the array with the new point. Okay, to create the vertices, we're doing a double loop, so a nested loop, going through our X and our Y starting at 0. And this is because we set our X size and our XY in the editor. for how wide and how long we want our terrain to be. And then we have the Perlin noise generator for the random z values. Okay, so we get our z value by taking the Perlin noise generator of a 2D vector, because we just want the x and the y, and we multiply the x by the noise scale. So this is the looping x value and the looping y value, times the noise scale, times 0.1 float, so there should probably be an f here as well, times the overall z multiplier. For debugging, what you can go ahead and do is you can check if your engine's there, and you can add an on-screen debug message, and you can actually print the z float value when it generates it, just so you can make sure that it is generating those different values. Then we go ahead and add those vertices to our t-array, and we add the UVs to our t-array. At that point, we call create triangles, which then, so now we have our vertices. So starting off at vertex 0, which is that bottom corner, we do another nested loop of our x and y values from our x size and y size that we set up, and then we're just adding in based upon the vertices that we just created before, and we're adding in the triangle vertex plus 1 and then y size plus 1, because we need 3 vertex points to actually create our triangle. And when you add the second set of triangle points, you're actually making 2 triangles touching each other, which actually makes a square. And then we go ahead and increment our vertexes. So the point is make 2 triangles to make a square, because triangles are the most efficient way for the GPUs to display our terrains. All right, so that's our procedural terrains. Whew, quite a bit there. Okay, looking at, let's go ahead and look at our projectile real quick. Okay, so this is one we worked on quite a few weeks ago. Okay, it was just setting up our default values. We have our impact effects, we have our projectile base materials, our splash base materials. So I like to make sure my variable names are easy to understand what it applies to. That way when I go away and then I come back like this 5 weeks later, I know what the heck I'm looking at. So as before, I like to use the material instance instead of the uMaterial interface. That way it forces the user to select only material instances to apply to our meshes. So we got our splash base material, our projectile base material. We have our impact effect, which is a Niagara effect. That's that splashback that we see. We pick a random color, and all of the different materials will then use this random color to assign it to the projectile, the decal, and the Niagara effect color. Okay, then we have our uMaterial instance dynamic. Okay, this is for our projectile, because we change the material every spawn, so we actually make it our material instance into a dynamic material based upon that random color. Same thing for the decal. Okay, and then we have our moon component. That's a default thing there. All right, let's see. On hit, that's default, but what we do once we get in there, that's what matters. So we'll come on down here. All the rest of this is basic setup. I think there's when begin play. So here we go ahead and create our RGB color here, and then we go ahead and keep the alpha as a 1 float, and we assign this to random color. If the projectile based mesh is set, then we go ahead and create the uMaterial dynamic based upon that mesh, and using the random color, we set the vector parameter to random color. And that's for the color. So if we go to the material, there's actually a parameter in there called color, which points to our outbound albedo. And then we check, is there a static mesh? If the static mesh is a set, then we go ahead and set that material to the static mesh, which is our projectile ball in this case here. Okay, on hit, so all this is default. Then we come in here, this is not default here. So we go ahead and get the frame number, because the splash effect is, or the decal, there's actually 4 different decals, and it picks 0, 1, 2, or 3 for the different decals. And then it randomly picks which one of those is going to be with a random float, 0 to 3. Okay, then we get our decal. We go ahead and spawn it at the location of the impact. We go ahead and get the world, splash base material. The F vector, we find that random float to adjust the random size. We get the hit location, and we get the hit normal. That way it's always flat on the surface. Let's see, and then we go ahead and create a dynamic material, and then we assign that dynamic material color and the random frame to the frame number. For now, we look at the Niagara impact. We go ahead and spawn at our hit location, get the world. We get our impact effect, which is our, we assign it in engine. We get the actor location, and then we get the hit normal rotation. That way it comes off perpendicular from the point of impact. Okay, and then we go ahead and set our color of the particle color, which is set in the engine, we set it to that random color that we defined here. Okay, finally, the procedural train. If we hit that procedural train, we get the impact point, and we call it ultra mesh. And then we go ahead and destroy that projectile. So that's if we hit the projectile hits the ground, we call the ultra mesh function from the procedural train, and then destroy it, destroy the projectile itself. That's it for the projectile. Let's see if we got the portal in here. Yes, we do. Okay, let's take a quick look at the portal, and it should be the last one. This is getting kind of a long video, so I don't want to make it too much longer. Okay, so we got our box component, which is actually our collision. We have our capture component, and then we obviously link to the game character as well, because we're using what direction the game character is facing to show what to see from the camera's perspective. Okay, so we got our static mesh, our scene capture, our render target. We set up our collision box. We have our link portal, which you can click the eyedropper to go ahead and set that, and then we have our portal material itself, which we set as a render target or a material instance. Okay. We have an overlap begin, so what happens when we overlap the target, and then we toggle on the player character, teleporting or not teleporting, that way we don't get stuck in an infinite loop. And then we go ahead and update our portals. This one's on the tick, because that when we change our camera angle, the direction the character is facing, you see that angle reflected on what you see on the other side of the portal. Alright, let's create our default subobjects, turn off the collision for our static mesh. You got the nice comments in here. It's always good to make sure your comments kind of explain what's going on. That way, when you come back 5 weeks later or months later, you'll know you'll have a roughly good idea of what's going on. It should be pretty self-explanatory. And the other part of that, as mentioned earlier, is make sure your variables make sense on what they're named. Just calling it base mat doesn't explain a whole lot on what is that base mat being applied to for material. Okay, begin play. We get the collision box. We're adding a dynamic event to this one on overlap begin. And the static mesh, we hide the static mesh set hidden in scene capture, because we don't want to see the static mesh itself through that capture camera. If the portal material set and a static mesh is set, then we go ahead and set the material to that portal material. Okay, we got our update portals. We'll come to that, look at that function in a sec. Okay, first we cast our player character. We also get our player controller. The player controller is for those fade effects. Okay, so if the player character exists, if the linked portal is set, and the character is not being teleported, that's a toggle on the player character. That's why we cast it to him. We go ahead and set it to true that the player is teleporting. We find the destination from the linked portal actor location. And then we check, is the player controller there? If yes, we go ahead and start a camera fade. Set the actor to the destination portal, and then go ahead and fade our camera back in. It's very brief. You can set it a little bit, few seconds longer if you actually want to be more noticeable. And then we go ahead and set a timer. After the in this case, we're only setting the timer to 1 second. So after the timer triggers, it goes ahead and sets the player character teleporting back to false for not teleporting. That allows us to teleport again. So toggle teleporting, and this is what we're calling inside the timer, and we set it back to false. Okay, last bit is the update the portal. Okay, so we find that player controller. We want to get that player controller. We want to get that linked portal. Then we go ahead and get the camera's location, and we want to do a transform the component, and we want to get the camera rotation. What that is, so if we're looking directly at the portal, we'll be also looking directly through the other portal. If we look off to the right, we'll actually be looking off to the right of the other portal from the portal that's standing in front of us. So if we're looking through the portal in front of us, we want to see what does that other portal see that we're linked to. So if we jump through, we know what we're jumping into or we're jumping towards. Such as if there's lava on the other side, you'd see the lava through in there, you probably wouldn't want to jump through. Okay, then we go ahead and combine those two together, the camera player's location plus location of the other linked portal's location. And then we go ahead and set the scene capture location and rotation to the combined location and the player camera rotation. That's for the scene capture. That's about it. Okay, let's see if there's anything else. Let's see, we talked about the code. Let's see, we talked about the repository. And we showed how everything was implemented. So if anybody ever has any questions, as always, ask down in the comments. This is one of the longer videos, and it's getting pretty far there into the game programming development course. I think I have like 2 classes left. Basically building a portfolio website, and the last class is fixing up these projects here to make them into more game-like. So for this particular project, what I'm going to do is I'm going to turn this into a 2-player procedural train game, and then when you shoot the train, instead of it making impact down on the ground, it's actually going to destroy those blocks. Or first, it'll hit that block and it'll become colored for that player to keep the other player from going into it. And then the second time you shoot it, actually destroy it, so the player can actually fall through the world and die. And the point is to be able to take out the player's health and to be able to prevent them from getting into strategic positions to be able to get you as well. Basically controlling the train, almost like a Splatoon effect type game, but you're destroying the game instead of just putting colors all over the ground. So that's what I'll probably end up doing to tweak this particular project into something a little bit more advanced. All right, as always, ask questions, and it was a great chat with y'all. Bye.